through 31 odd, and 41 through 45 odd. Alright, this is going to be a long set of homework problems, so I will give you 2 days to work on it. So work on it Friday and Monday. So this lesson, we won't have a lesson on over this weekend. So let's go ahead and take care of this lesson here. Okay, in this lesson we're talking about end behavior. End behavior. So end behavior. Okay, what is end behavior? That's when we're talking about end behavior, we're talking about when x goes to either positive infinity or when x goes to negative infinity, and that is known as the end behavior. Let's get some theorems and definitions, and then we'll go on and find the end behavior of different problems. Okay, first one on page 131. Okay, page 131, theorem 2.3. This is theorem 2.3.1, and that states the limit as x goes to negative infinity of k is equal to k. What that means is, if I just put in some numbers, limit as x goes to negative infinity some constant function, let's say 5, it's going to be 5. And limit as x goes to, let's say, negative infinity of, let's say, 2, it's going to be 2. So basically, if you look at this function, if that's 5, that's a horizontal line. So what happens when you go to the end? It stays as 5. Well, let's go ahead while we're there. Negative infinity, or going to the negative infinity, it's going to stay 5. And if it goes to positive infinity, okay, and it's going to stay 5 also. So it doesn't matter if it goes to negative infinity or positive infinity, okay, we're going to get that same constant. Alright, how about the next part of this, which says limit as x goes to negative infinity of x? Well, that's negative infinity, and why is that? So if you look at this graph, y is equal to x, that's your y is equal to x. Okay, when you go to the left, it's going down, so therefore it's going to negative infinity. But what do you think is going to happen if you go to positive infinity? Okay, obviously when you go to the right, it's going up to positive infinity, so it'll be positive infinity. Okay, and then this is the most important one. Limit as x goes to negative infinity of 1 over x. But if you remember the graph 1 over x, that has a vertical asymptote at 0, and it's going to look like this. On the right side, it's going to look like that. It's one of those hyperbolas known as degenerate hyperbola. So when you go to negative infinity, okay, that means this way, that's going to go to 0. It's getting closer to 0. And limit as x goes to positive infinity of 1 over x. Okay, so when you go to the right, it's going to 0 also. Okay, that means when the bottom of the fraction gets really, really big, the fraction gets really, really small. Okay, it doesn't matter if it's positive or negative. Okay, that's the first theorem. Okay, and then of course this everything we've learned in last section about sum and difference and product and quotient rules and square rules, they all apply. So on page 132, I want you to take a look at theorem 2.3.2 without me going over all of that. Same rules that I taught you yesterday applies to infinity also. Okay, so let's move on and let's do a few problems. Okay, and let's start with example number 1. So try to make this lesson short rather than me repeating what you have in your book. Okay, so example number 1, it says limit as x goes to positive infinity of 2x to the 5th is equal to, Okay, positive infinity. Because if you put in big positive number there, raised to the 5th power, it's going to get really big. But what about limit as x goes to negative infinity of 2x to the 5th? Well, when you put a big negative number and raise it to 5th power, you're going to get negative. So it means it's going to go to negative infinity. Okay, that's example number. That's pretty straightforward. And if you had a minus in front of that, then this will not be positive infinity, it'll be negative infinity. And vice versa, if you have negative in front of that, this will not be negative infinity, it'll be positive infinity. Okay, let's move on to the next example. Okay, this is example number 2 on page 134. Okay, this is a polynomial, so x goes to negative infinity of 7x to the 5th minus 4x to the 3rd plus 2x minus 9. Well, we can evaluate each one of these. Okay, well, of course, limit of a constant is going to be constant, and that's going to go to negative infinity when I put in, when this becomes big negative number, that's going to go to negative times positive infinity. But it doesn't matter. This is the big dog right there. So the big dog determines what happens to the whole thing. So you might as well ignore all of this and just look at the leading term. So this is going to be the same thing as x goes to negative infinity of 7x to the 5th. If you just look at that, that will give you the answer. So when you put a big negative number there and raise it to 5th power, it's going to become a big negative, so it's going to go to negative infinity. So all of this is not really relevant at the end behavior. Okay, let's say we have something like this: limit as x goes to negative infinity of negative 4x to the 8th plus 17x to the 3rd, okay, minus 5x plus 1. Well, you know what? We don't need to worry about all of this because the big dog here will tell us what will happen. So I might as well just look at this as a limit as x goes to negative infinity of negative 4x to the 8th. So if I put a big negative number, raise it to an even power, they'll become positive, but the negative in front of that will make that turn it back into negative, so it's going to go to negative infinity. Okay, now comes the next example, example number 3. Okay, so this is limit as x goes to positive infinity, which is 3 of a function 3x plus 5 all that over 6x minus 8. Okay, first I'm going to show you the long way, the way the book shows you. Then I'm going to show you the ancient Indian secret. So let's do it the long way. To determine what happens to this when you have a fraction, what we're going to do is we're going to take the highest power of the x, whether it's on the top or the bottom, we're going to multiply that by 1 over that. So 1 over x, but if I do that I have to multiply the bottom by 1 over x also. When I multiply this through, okay, now this will look like a limit as x goes to positive infinity of this times this will become 3 plus 5 over x, and this times this is going to become 6 minus 8 over x. Now when I take a limit, obviously this fraction right there, because the bottom's getting big, this is going to go to 0. Since the bottom here is getting big, this is going to go to 0. So the top will go to 3, bottom will go to 6, which reduces to 1 over 2. So what is the ancient Indian secret? So if you have something like this, x goes to positive or negative infinity, so I have a 3x plus 5 over 6x plus minus 8. Okay, so if you have that, minus 8, you just have to look at the leading coefficient. Okay, so if the powers match up, top and the bottom, we're going to just look at the leading coefficients. The leading coefficient is going to be 3 over 6. That reduces to 1 over 2. Okay, so if the powers match up, both top and the bottom, then it goes to leading coefficients. Okay, let's see what happens when they don't match up, which is in example number 4. Okay, so example number 4, limit as x goes to negative infinity I have a 4x squared minus x, all that over 2x to the third minus 5. Okay, how do you find the limit of that? Okay, let's do it the old-fashioned way first. So my highest power is x to the third, so I'm going to multiply top by 1 over x to the third. I'm going to multiply the bottom by 1 over x to the third. Okay, when I do that, okay, this simplifies to limit as x goes to negative infinity. This times this is going to give me 4 over x. Okay, and then this times that. The second term is going to give me negative 1 over x squared. And then in the bottom, when I multiply that, I'm going to get a 2 minus 5 over x to the third. Now, when x goes to negative infinity, okay, this is going to go to 0. And then this is going to go to 0 also, because the bottom is getting really, really big. Okay, and this is going to go to 0. So top is going to 0, but the bottom is going to go to 2 minus 0, which is 2. 0 over 2 is 0. So what is the ancient Indian secret? Okay, limit goes to positive or negative infinity, doesn't really matter. Okay, let's say negative infinity of 4x squared minus x, all that over 2x to the third minus 5. Okay, if the power on the bottom is bigger than power on the top, okay, we're going to check that. If that happens, it's going to go to 0. Okay, alright, so let's do the second example in that. So limit as x goes to negative infinity of, I have a 5x to the third minus 2x squared plus 1, all that over 3x plus 5. Again, I'm going to do it the old-fashioned way first. Multiply top by 1 over x to the third. That means I got to multiply bottom by 1 over x to the third. Let's go ahead and clean this up a little bit. X goes to negative infinity. Okay, when I multiply this through, I'm going to get a 5 minus 2 over x plus 1 over x to the third. All that over. When I multiply that through, I'm going to get 3 over x squared. Okay, and then I'm going to get plus 5 over x to the third. Right, this is going to go to 0 when x goes to negative infinity. This is going to go to 0, so the top's going to go to 5. Bottom, that's going to go to 0. Okay, and then that's going to go to 0. Okay, so bottom's going to 0, so when that happens, limit does not exist. Okay, limit does not exist. Okay, so when the bottom goes to 0 of a fraction, because the bottom of the fraction gets 0, this thing's going to blow up into a big number, so limit does not exist. Now, we'll go to positive infinity and negative infinity. It depends on that value right there. Since that's a positive value, the curve is going to go to positive infinity, but we can also say limit does not exist. Okay? Alright, so let's get to example number 5. Example number 5, and that's on page 135. Alright, now comes a radical. So limit as x goes to positive infinity of third root of 3x plus 5, all that over 6x minus 8. Well, same rules apply when we did last section. When we take a limit of a radical, we can go inside, take the limit, and then take a third root. So this is limit as x goes to positive infinity of 3x plus 5, all that over 6x minus 8. Right, if you notice in this fraction, the powers match up. Power on the top is 1, so power on the bottom is 1. So it's going to go to leading coefficient, so that means third root of 3 over 6, or third root of 1/2. And that is the limit. Okay, so what happens when we get something like number 6? Okay, this is the hard one here. Alright, so you better pay attention. Okay, this is example number 6. You will not understand this when you read the book. Okay, so book is more complicated than what I'm going to show you. Okay, so let's take a look at limit as x goes to positive infinity of a square root of x squared plus 2, all that over 3x minus 6. Alright, how do I find the limit of this? Okay, well, I notice I have x squared on the top and I have x on the bottom, but I can't get inside the radical, okay, unless I multiply this by 1 over square root of x squared. Well, what is 1 over square root of x squared? Well, that's the same thing as 1 over x. That's what I got to multiply the bottom by. Okay, so seems pretty straightforward. This is same as this, so I'm multiplying by 1, but I got to put the radical so I can go inside the radical. So let's do some algebra. Limit as x goes to positive infinity. This becomes square root. When the x squared goes inside here, that's going to become 1 plus 2 over x squared. Okay, so that's okay. So in the bottom, I'm going to get 3 minus 6 over x. Now when we take a limit, we know what's going to happen to that. The bottom's getting really big, so that's going to go to 0. Okay, so the top's going to go to rad 1, and then bottom here of this fraction, that's going to go to 0. So the bottom's going to go to 3, so I have a rad 1 over 3, which is 1/3. Well, that's pretty easy. Okay, that makes sense. Now comes the second part, which is tricky. Okay, here we go. Limit as x goes to negative infinity. Okay, square root of x squared plus 2. You might want to watch this twice. Okay, pause it, think about it. Okay, let's say we do the same trick. We're going to go to negative infinity. Okay, I write that 1 over square root of x squared. Okay, and I'm going to multiply the bottom by 1 over x. Okay, now remember here, this is same as this, so it reduces to 1, so we can multiply and doesn't change anything. But because I'm going to negative infinity, this will be negative. Because square root of x squared, this is positive. If you reduce this, that reduces to a negative 1. It doesn't reduce to a positive 1 like this one does up here on the top. Okay, this one's positive 1. But this one here, actually, that fraction actually reduces to negative 1. You can't multiply something by negative 1 and keep the original problem the same. So because this is negative 1, I have to adjust for this by putting a negative on this, so that will turn this back into a positive. Well, this negative, I don't have to keep it there. I might as well just move it out in the front. So that's what I'm going to do. So limit as x goes to negative infinity, and we'll move it out in the front, and then go ahead and multiply this through, which is going to give me 1 plus 2 over x squared, and then all that over. When I multiply the bottom out right there, I'm going to get a 3 minus 6 over x. That's going to go to 0. That's going to go to 0. So the top's going to go to square root of negative 1, which is negative 1. Bottom's going to go to 3. Okay, what this means is, and that's how we find horizontal asymptotes. That's a definition of horizontal asymptote. Okay, when you check the end behavior, limit as x goes to positive infinity of f of x. Okay, and limit as x goes to negative infinity of f of x. It is going to give us the horizontal asymptote. Okay, so what it means is that the first part, when you go to positive infinity, our horizontal asymptote is going to be at 1/3. When you're going to go to negative infinity, the horizontal asymptote is going to be at negative 1/3. So the curve actually flattens out at two different places. Okay, so if you were to sketch this curve, that's going to be like 1/3. Okay, there's your horizontal asymptote. So when I go to the right, the curve's going to, I don't know what's going to happen here, but it's going to flatten out like that. And then when I go to the left, my horizontal asymptote's here, and it's going to flatten out like that. Okay, so something like that. So that's how we determine horizontal asymptotes, by checking the end behavior. Alright, we have one more problem. That was the hardest one. Okay, so it's a tricky one, so you have that at homework. I'm going to put that on the quiz too. So this is example number 7. This is not bad. So limit as x goes to positive infinity of a square root of x to the 6 plus 5 minus x to the third. Well, this is really over 1. Okay, I'm writing over 1 for a reason. If I try to find the limit of this by putting in infinity for x here and here, I'm going to get infinity minus infinity, which is going to give me a 0, or square root of infinity minus infinity, which makes no sense. So what I have to do is I got to rationalize my numerator. Instead of denominator, I'm rationalizing the numerator. So it'll be square root of x to the 6 plus 5, my plus x to the third, and multiply the denominator by the same thing, square root of x to the 6 plus 5 plus x to the third. So I have a limit as x goes to positive infinity. Top is difference of two squares, so I'm going to get x to the 6 plus 5 minus the second term squared, which is x to the 6th. All that over, square root of x to the 6th plus 5 plus x to the third. Well, now when I simplify, x to the 6th is going to cancel out. This now looks like limit as x goes to positive infinity of 5 over square root of x to the 6th plus 5 plus x to the third. Of course, the power on the bottom is larger than the power on the top, so therefore I can use my ancient Indian secret. It's going to go to 0. Okay, and the same thing applies when you have a negative, so I'm not going to do that example for you. Okay, so that is pretty much it. Okay, so let's stop right there. I'll give you Friday and Monday to work on this homework. Okay, and then we'll do